One, two, three.
What is up, team? Today, day 2, quadratic formula. This one is a bit trickier than yesterday. If you've not watched the other video first, please do so. It's much simpler. This is supposed to be trickier than that. As evidence of it being more tricky, this is the second time I've done this one because the first one I got to the very end and I realized I screwed it up at the very beginning. So details, super important. Stick with me as we do this. Same formula, same step-by-step as the last video. Let's do it. Solve for x. X squared plus 3 equals 6x. We want to get everything on one side. We're solving for 0. That's our first step. So subtract 6x from the right. Subtract 6x from the left. And we learn x squared minus 6x plus 3 equals 0. All right, step 1 is done. Step 2, plug the A, B, and C values into the formula. Let's identify the A's, B's, and C's. Here's where my mistake came in last time. And then we'll head over to the formula. So we know our A is 1, our B is negative 6, and our C is 3. There's a 1 right here, negative 6 is our B, and C is 3. Boom. Okay, plug them into the formula. We know that x equals negative b, so in our case that's a negative 6 plus or minus the square root of negative 6 squared, because it's b squared, and our b is negative 6, minus 4 times a, so our a is 1, times c, which is 3, all over 2 times 1. Woof. Okay, this one's a doozy. We're going to break it down piece by piece. Looking at it, like even me looking at this right now, I'm like, that's intimidating. There's so much going on, parentheses, negatives, exponents, radicals. Lots are happening. We're just going to do it little by little, and we'll get to a point where it's a whole lot simpler. Okay, negative 6. Well, negative, that's a positive. So we're just going to replace that with a positive 6. The plus or minus, that comes into play later. That's step 4. We're going to leave it alone for now. Now we have a negative 6 squared. Negative 6 times negative 6 is positive 36, minus 4 times a times c. So 4 times 1, that's 4. 4 times 3, that is 12. Now on the bottom, 2 times 1, that is 2. Cool. It's getting simpler. 6 plus or minus the square root. 36 minus 12, that's 24, all over 2. Okay, now, at this point in time, 24, not a perfect square. 25, that's a perfect square. 24, not so much. So what we're going to do is get our calculator out. We're going to get a decimal approximation of the square root of 24. And what that changes in this problem is it's going to give us an approximate answer. It won't be exact, and that's okay. We can live with a very close approximation. We're going to round to the nearest hundredth. But one thing that does change is we're going to stop using these equal signs because it's not equal. It's approximately. So they're going to look like equal signs, but they're going to be little squigglies. So get used to that for the rest of this problem, and whenever you're doing decimal approximations, not just for quadratic formula, but forever. If you're ever rounding, we really should be using these squiggly lines. Okay, so I'm going to just do the square root of 24 here. So square root of 24 equals, my calculator says 4.8989 79486, blah, blah, blah. So it's going to round to 4.90. Cool. So it ends up being 6 plus 4.90. Interestingly enough, as much as I want to round to the nearest hundredth, the nearest hundredth does have a 0 at the end. So we're going to call it 4.9. And that's okay. We can live with that. Okay, this is as simple as it's going to get before we split things up. So step 4, split into 2 equations and evaluate. This is where we have 6 plus or minus 4.90. So we're going to do the plus equation, the minus equation, and then we'll see what our solutions are. So the plus. This is where we have x is approximately 6 plus 4.9 over 2. And then our negative, 6 minus 4.9 over 2. Remember, the key difference here, this is where we're acknowledging the plus sign in the plus or minus. This one is where we're acknowledging the minus sign. We're getting 2 solutions, no surprise. We're dealing with a quadratic. We know the parabola is probably going to cross the x-axis twice. So having 2 solutions should not be a surprise. One thing I should have written a little bit better here, I should have x is approximately that stuff. My mistake. Okay, over here now. Let's evaluate our numerator. 6 plus 4.9, well, that ends up being 10.9. And we divide that by 2. So this x over here is going to be 5.45. Cool. This side, 6 minus 4.9 is our numerator. Well, I know 6 minus 5 is 1, so this is going to be a little bit bigger than that. I'm going to have a 1.1 on top, divided by 2. So x is approximately, let's see, 0.55, I think is what it ends up being. Of course, you can use your calculator for this. I'm trying to zoom through for the sake of the video. So what does this stuff mean? Well, if x is 5.45 and x is 0.55, this means that if we were to graph this, which we totally could do, we would probably have a really hard time finding out exactly what the y-intercepts were. Or sorry, the x-intercepts were. I don't think I would look at a graph and say like, oh, that's at 5.45. I'd have a hard time seeing that. I'd probably call it 5.5, and that is approximating too much. This is already an approximation. Same is true over here with our 0.55. In the same way, this one cannot be factored. The previous video, the one from yesterday, we could have factored it and done it much, much quicker. This one, not factorable. We must use the quadratic formula on this one, which makes sense. It got real messy. Generally, when you have to use the quadratic formula, it's gonna be some messy business. So be prepared for that. Be prepared to pay attention to details and just follow it step by step. So I don't think it's like a hard work, but it's tedious and it's detail oriented. Both things I'm not great at. I'm not super patient and I'm not good at details. But if I can do it, I believe in you. Okay, let's dive into some practice problems. You got this.